All right. Thank you and good afternoon or good morning. I could talk all day about this topic. I could start with AI. I could go into predictive maintenance. There's a lot of spaces I could go. But realistically, we want to go from the AI to how do you get there? What does it mean? How do you get started? And we touched on that a little bit. I'm going to try to go a little bit deeper. But first, I find the intersection of how we arrive at IT and OT to be incredibly interesting because everybody gets there differently. So I'll start with a quick little bit of my background of how I got there, and then I'll transition into the problem that we were trying to solve and how we used HighByte to solve it. So to start, my degree is electrical engineering, and I did manufacturing while I was in college. So I kind of have that sort of manufacturer's mindset. And once you kind of see that efficiency and you learn and you think about the world that way, you can never unsee it, right? So then I went to FedEx and I spent the first 8 years of my career in industrial controls. And I did everything from the planning and the design into the hands-on in the PLC programming, doing the AI, doing the user interface and troubleshooting, the 24/7 support, all of that. After that, I took some other engineering positions within the company before finally getting recruited into IT. So I was recruited into IT because of my business background and understanding. They really needed people that understood the processes and how to marry them together with what IT was building and the systems they were creating. But when I got there, they started saying, hey, somebody needs this data from the edge, from this thing called a PLC. We don't know what that is, but you apparently used to do something with it. So I kept getting pulled into these conversations time and time again and started doing these integrations. So for the last 7 years, I've done a lot of IT/OT integrations. That's just part of what I do. So one of the first ones, so into the problem that we really ran into, the first problem was I got involved in a robotics implementation that we were doing. And it took probably about a year to get it stood up. And the reason why is because it had end-to-end data flows and integrations from the edge into our data centers, into our cloud, customer cloud. There was a lot of folks that wanted a lot of data in a lot of different places. So we had to go through the infrastructure build out. We had to provision servers. We had to get all of it approved through our security folks, which that takes a while, especially for every step you add. It's another step for security, right? So till it was all said and done, till we went from concept, hey, we need this, till we actually had the robot doing the thing it was supposed to be doing, it was right about 1 year. It took about 3 weeks for us to realize that the vendor we were working with wasn't going to be able to meet our needs. But the problem was we spent a year standing this up. So the business did not want to let it go. So we spent another year trying to salvage what we had already stood up. Because of that infrastructure and that build out took so long, they did not want to let that die. So finally, about the time that project ended, I got asked to do another integration with another device that was very similar. And I realized I was going to have to go down the same path, take the same steps. The challenge is I also realized that everything that I had spent that year doing, none of it was reusable. I had to start all over again with every step of the way, onboarding a new vendor, standing up new hardware, provisioning, different data centers. So, realized really quickly that this wasn't sustainable and there has to be a better way. So that's when I started my personal journey of looking into what other architectures are out there where we can basically build, in my mind, the highway. How do we create the highway from our edge into our data centers and into our cloud so that in the future, instead of creating this giant end-to-end integration, we can simply just create the on-ramp. We can do local integrations where we can just plug in and move data, and we can skip all that because all that's already been built. All that's already been vouched for, all that's already been blessed by security, all of it's already in place, right? At that same time, problem number 2 was being worked on by a different team, by our maintenance team. They were looking at what is next after preventative maintenance. And about that same time, we hit the pandemic. So FedEx's buildings are built with peak volumes in mind, meaning that and our peak is about a month and a half, which means outside of that, we typically have capacity to do things for downtime outages. We usually have, depending on the building, somewhere between 4 to 8 hours of downtime a day to run our preventative maintenance programs. That's things like, oiling chains, checking bearings, all kinds of whatever systems we want to do. We have a really good system. It worked really well, but it was also labor intensive, time intensive, and very expensive to do it that way. And when the pandemic hit, almost literally overnight, we lost those windows. They went away. We were running some buildings 24/7 for almost 2 years straight with no stop to deliver all those packages everybody was ordering offline. So during that time, our maintenance crew said, hey, we need to get there. We need to figure out predictive maintenance. So they reached out to Deloitte, actually, who's in the room and will be speaking later today. And they worked with them and said, hey, can you design us a solution? Deloitte came up with a solution. They brought it in. Deloitte and our business partners came to me and said, hey, we're going to need help from the IT side. When I saw what they were proposing, I instantly understood and recognized that we did not have two problems. We had one problem that was the same. It was a data problem. It was how do I collect and move that data from one place at the edge to someplace else where a process can be done to gain the insights that we need to gain value, right? So I asked them, I said, hey, this is great, and this is definitely going to solve the predictive maintenance solution, but what would it take for us to get to a true unified namespace? Now, we could talk about the unified namespace, but that's not the point of this conference, so we can talk about it offline, or you can Google it. There's lots of information out there. But they came back and said, hey, we can use this product called HighByte that I think is going to get you where you want to go. So we looked at it, we brought it in, and we tried it. And HighByte gave us several advantages. The first big one is the first problem that it really solved for us was through contextualization. And I think this is really where all of these things we talk about AI and start dreaming about what can be. I think this is the point where it all kind of starts hitting reality and how you really start to take advantage and move the needle towards that AI integration. And I say that because what this allowed us to do for my controls people in the room that have ever tried to get that data, your operational data out of your PLCs, you may find it very challenging. One of the big challenges we had is we can use historians. The problem with a historian is it takes in a ton of data. Then you need somebody to do something with that data to pull it out and extract those insights. Then you need that person to go somewhere to drive the actual behavior and change the behavior to get somebody to take action to actually realize the savings, right? So in our scale, that's okay if you're a plant, if you're two plants, if you're three plants. We're over 170 sites that are spread out throughout North America. It just wasn't feasible and cost effective enough for us to have all of these historians out there to manage them, have teams of people doing this data mining, and then trying to drive these insights to truly get the value out. So after a couple POCs, we kind of abandoned that concept. A few years after that, the concept of the data lake arrived. So we're pumping data into the data lake. And we did this on a POC basis as well, but we have thousands of PLCs. We have, ridiculous amounts of data that we're pumping into these locations. And we found a couple things. Number one, you still don't get all the data or all the data that you want. You still have to make sacrifices because you can't push that much data over your networks. The other thing we found is that when we get our data scientists involved, they spend a lot of time spinning their wheels because they don't truly know or understand what that data is always representing. And we found there was a lot of misassumptions in there where they would say, oh, I thought this was this. And then when we get to the end, so why is it not working? We talk to the tech level and they're like, well, that's not what that does. That's not what that tag value means. So what contextualization really did for us was solve that how we get our operational data out of our PLCs. And the way that it does that, and the example I like to give, because again, remember, I have to sell this up. So I like to give a stripped down example. And when we talk about data coming from OT devices like PLCs, we're often talking about tag value. So for an example, you're going to pull the value and it's going to be 70, but that 70 doesn't really mean anything at that point, right? Could it be a temperature? It could be a pressure. It could be a count. So what HighByte allows us to do is it allows us to pull that value in and then add that context. So now we know that it's 70 degrees Fahrenheit. It also allows us to connect other data sources and bring in other data elements. For example, we could bring in with 80 degrees ambient temperature. So now we know it's 70 degrees Fahrenheit at 80 degrees ambient temperature. We also can do things like timestamp it, and we can pull in the asset information. It's all there. And then we can take all that different data, package it up into a single data element, and then we can publish that into our MQTT namespace, or however you want to publish it. And that can be then consumed by anybody who wants to consume it. And really what that does is now your data scientists, when they look at it, they're pretty darn sure what that is. Oh, this is a temperature reading taken at this time from this machine on this bearing. And they can take action on that pretty quickly. They don't have to spend time churning through that. So that's really what contextualization got us. The other big thing that they were able to help us with, or that HighByte helps with, is we were able to use the concept of data pipelines. And data pipelines are basically models. So we're able to create a model, for example, of a VFD. And then we're able to apply that model again and again and again. We don't have to keep creating that integration. So what that allowed us to do is it took us a little bit to stand up our very first site, our POC site. But once we went from site 1 out to site 41, we did that in about 6 months. So we were able to roll that out. And the reason we were able to is because we're able to use that one pipeline that represents our VFDs over again and again and again. So not only did it let us expand quickly, it also helps future-proof us in that it's all just configuration at that point. So for example, in a site, and we do expand a lot, we may roll out to site A, and then we might come back 2 years later and we might expand it. So we might go from having 5 VFDs to having 10 VFDs. And when that happens, all we have to do is go in and change that configuration. It's not a complete rewrite. It's not a complete reinstall. It's not a giant recommissioning effort. All we have to do is just go in and just change the number, and it's going to recognize that, hey, I got 5 more VFDs, and it doesn't really care. It's just going to start processing the data and sending it downstream into our AI systems. And then finally, the last thing that it really did for us is HighByte's built on modern IT architecture, meaning it takes advantage of containerization. And containerization is really a game changer for us. And I know for some in the room, you're probably really familiar with it. Others are probably terrified of that name. When I talk about containerization, I am actually not even talking about Kubernetes and everything that goes with it. While that is definitely possible to run it in those environments, we actually do not run Kubernetes at the edge yet. So we didn't want to wait. So we said, well, we'll just run a container as a container then. So we run only the container, not an orchestration at the edge. So it was actually pretty quick and pretty simple for us to learn and stand up as a group. And what that allows us to do is, an example I'll give is when we went from the last major release, we got it at 9 o'clock in the morning from HighByte. And we put it onto a build box to make sure that it builds and launches without failure, and it did. Then we put it into our test facility and made sure that it was able to have the data connections and things we expected, and it did. And then we rolled out to our beta sites. We did all that by 10:30 in the morning. So about an hour and a half to get us in production with a major upgrade. After that, we let it run for about 12 hours or so. And that evening, we pushed it to the remaining sites. So in less than 24 hours, we did a major release upgrade because there were features in there we wanted to take advantage of. And we did it in less than 24 hours to 40 sites, all running production, all without missing any data along the way. And now, just for those that may not be familiar, if you would think, well, you could do that, sure, but it's a bit reckless. The brilliance of the container is the simple fact that if you do find anomalies and issues, you can simply go back and redeploy the last known configuration and it'll pick it up. So those are the problems that we had, and that's how we employed HighByte. And if you look, this is basically our basic architecture. This is nothing fancy. You can find this in almost every company now has a diagram that looks very similar to this. You see PLC simulating our edge, and whatever other devices we may get. It comes to an on-prem server where we have HighByte. HighByte is really what is contextualizing that for us. And then we are taking that highly contextualized data. We are publishing it into our namespace. We have 41 namespaces. We have a namespace per site, at site, on location for future use cases. And then we set them all up into a single enterprise level namespace as well. And then from that namespace, we can go into the cloud. And we can go to any cloud we want at that point. It's just a simple connection. So the only other thing that I have before Where are we at? Perfect. Before we're done, I do want to just tie it in a little bit to the AI conversation and where we're going. Our founder, Fred Smith, recently passed away. And one of the things that was always so great to hear him speak, when you asked him about the future, because he was such a great thinker of the future, such a great visionary, he would always give you a story that was a history story. He would always take you back to something in history to run the comparison against where we were going. And to do that, when I think about AI, excuse me, when I think about AI and where we're at and where this is all going, I kind of look at the same as like manufacturing, right? When we started manufacturing, basic concepts of manufacturing took things forward very quickly, right? You gained a ton of efficiency, and the slide has nothing to do with it. Sorry. But one of the, you got a lot of benefits by standing up manufacturing, and a lot of really quickly. But one of the things that happened is early manufacturers often had huge material inefficiencies, right? And as we have evolved, you've seen that's really where a lot of the improvements have come. It's eliminating that waste. It's being more specific, more mindful, and consuming less resources to make the thing that you're making, because ultimately it ends up being cheaper, right? I see the same thing when we start talking about AI and the same journey. Right now, there's this real push of just pushing everything into these clouds and into these giant models. But really, I think the companies that will do it best, and I think this is where HighByte really shines, is it's going to be the ones that really strip it down and send that highly concentrated data that is very contextualized into those models so that it can feed off them. And as we heard earlier today, we already know that processing power, it isn't free. And it does have an impact. We know that it takes energy. We know that it takes water. We know that it takes these resources. So the less that you need to process because you've already done it, the better off the more effective your AI is going to be. So this is one of the areas where I am most passionate about, is because I feel like there's so much focus on the end results and the promise of AI that there really isn't enough conversation in this data ops piece of how do I get the data in there? What data do I get in there? What does it look like? So, I can really quickly, this is our final architecture. There's some things that obviously are not in here, but you can see where we have smart things connecting to our devices, and then our devices go into what we call a gateway, and our gateway is living at the edge. And so there's 41, however many sites we have is how many of these we have. And again, you can look at almost any company, you're going to see darn near the same model. We pump it into a data center. You can go directly to the cloud. The reason that we go to a data center is because we think we might have some other integrations down the road and other use cases that make it more convenient to be in the data to be in a data center versus cloud. And then we go into our cloud and our cloud compute. This model is actually for our predictive maintenance solution, and this does go through from start to finish without any human interaction. The first human interaction we have is when the maintenance technician receives his work order to go and check on the thing that it thinks is going to break. And they're able to go out, they check it, and then they either come back with, yes, it worked, or no, it didn't. And we have they've been pretty good with it. I think right now they're on about a 60% capture rate on being accurate, which isn't too bad. Some of that though is definitely, there is a cultural piece to this. There's a human piece to this that we continue to work through with people just accepting it and trusting your models. And then there's also definitely a tuning session within those models, where you don't want to be over aggressive and predict too much because people start to ignore it. But you want to make sure you're predicting the big failures. And one of the things we'll see is people will go and say, oh no, it's fine, and close it out. And then we notice there's a work order 2 weeks later to replace the thing in a production failure. So, it's been very, interesting, flow for us. So, I can take questions on any of that, really, if there are any.
Just a quick one on the architecture. Where's that data center? Is that your own data center in one of your locations?
No, we partner with a third party that runs the data center. This one is probably in Las Vegas.
And there's just the one for all 40 sites, or do you have?
This is just one data center. Yeah, okay. And all this is just running on VMs.
All right, thank you.
Mm-hmm.
Good question. I guess two quick questions. My understanding of distribution facilities, the events are very, very fast. Can you talk about how you handled like data acquisition for very fast events?
Yeah, so I mean, that's part of why you see the on-prem component of it. And that's one of the big decision factors in why we have currently 41, but we have a localized unified namespace that we're publishing into before we go into the consolidated net level. And it's because down the road, we believe that we'll be passing that data through that unified namespace, and we're going to need those faster response times. But yeah, absolutely, that is a consideration for us.
Great. The other question I had was, I know this gets more philosophical because UNS always opens up a can of worms, but in terms of where your users interact with data, where most people in your org kind of consider the UNS? Is it everything, or is it certain parts, or how do people think about UNS within your org?
Yeah, so that's actually really interesting and a really interesting question. And I guess my answer would be, hopefully they don't think about it at all. And I think that's really where we're at. Our legacy folks that have been doing PLC and data forever at that level, they're still doing it. Nothing has changed in their world, except for now they have more visibility and more tools on the back end that they are able to see and leverage. As far as on the upstream end of that, our in-between people don't really care either. It's, data's data, server's a server. It's really leveraging and laying within the existing infrastructure we have. This really didn't open anything new for us. From we need this, set of skills. We already had them. We already had most of the infrastructure in place. And then the same is true on the back end. We have data scientists that are directly interacting with this data. And it's been, really good for them because like I talked about earlier, they understand the data much better. They don't have to mine through and go, well, I got this value from this thing that's called a PLC that's maybe a temperature. They don't have to know that anymore. They don't have to guess anymore because it's pretty obvious what this data is. And it's pretty well mapped out. So they're the ones that probably interact with the data the most, which in my mind is great because that's what they're there for. That's what they should be doing. And then they are putting some really cool outputs where we're able to see some cool insights out of that, out of the PLC data, because that is our operational data that they're able to share and publish out to managers and stuff that run the facility so that they can actually see how to do things like reduce rehandle and run more intelligently. Yeah.
Hi, I'm interested in the image capture stuff that you have going on. So I guess maybe a couple questions. Are you pushing images through MQTT, and what are you using the images for?
Not yet. Not yet. And there is a piece of there's a piece of HighByte in there that we are interested in to potentially take advantage of that. Okay.
Mm-hmm. Okay, my question was, at the beginning you spoke about the use of historians, and I don't see anywhere on your map a historian. Have you replaced all your historians just by storing everything via MQTT? What does that look like?
Oh yeah, this is one of my favorite topics. We don't have them because we didn't have them. They were a failure out of the gate for us. Because again, in our world, we're looking to see how do we get the money back. It's great if you're collecting your data, but if you're not taking action on that data to be able to reduce your operation costs or to run more efficiently, it's just a waste of money. And that's really where we were at. We weren't able to do that at scale across 170 plus sites. Mm-hmm. So we abandoned that effort pretty early on. We never really got anywhere with it. That was probably 15 years ago now. So that one kind of died off. There's a time and a place to have historical data. And certainly if you are like a drug manufacturer where you have to have a record of what it is you did and why you did it, that might be a great use for a historian and maybe a different use case. But in our world, we don't care. We want to get your package from point A to point B as quickly as possible. So we want to use the data real time and then be done with it. Now we do have sections where we do strip off things like tracking and everything, but we don't want to be in the habit of storing data just to store it. If that data that we're keeping isn't adding value, we want to get rid of it. And that kind of goes back to that whole, I started in manufacturing and kind of got those messages. I still think about data the exact same way. Why am I moving, gigabytes of data? when I only need megabytes? It doesn't make any sense. Why am I storing tons of data when I don't really need it?
Okay. And a follow-up, you've got the local MQTT broker within HighByte and then your enterprise one. Are you just making a complete duplication, pushing everything live, or is that done on a schedule? How does the link between each individual site and your data center work?
So we do have some different ones. Depends on what it is. Most of it will be on change. We do have some that are on sample rates, and that's just due to the nature of the data.
Okay.
Oh, Steve.
I need on me. Hey, Kevin. So Brad mentioned that predictive maintenance is kind of the low hanging fruit. You started there as well, right? So where do you see it going next? I mean, do you have other ideas on what I'm sure you're always conjuring up something.
Yeah. So ever since the beginning, I recognize that, I've always said since day one, predictive maintenance is what's going to pay for this. And it is. And it has. Like, that's where your payback, that's what's going to pay for it. But it's not, it's just the beginning. There's so much more opportunity here. From our side, we have the opportunity to move more operational data. And I just got to think about what I can and can't say about certain things. But, I'll say it this way. We have a really good internally built system for moving our packages. But one of the challenges is we collect a lot of that operational data from our PLCs and do a summary of it, and we publish that summary up. The challenge is there's more data than what is in that summary. Now, it's a very good summary, but what that means is our folks in the field and our folks that are trying to do their planning and solve problems and use data to solve those problems, when they need an additional piece of data, we often have it available. It does exist, but they can't get it because they have to ask the same team that's trying to figure out how to deliver what's next in our delivery and how we move product across our facilities. They have to ask them to and prioritize against their major initiatives to get this data element. And typically that's a real hard sell. So we don't really get that because they're dependent. One of the areas where this could really be useful is if we start publishing that data into a namespace from the PLC instead of through this home-built program, it would give us the ability to very quickly enable that data whenever there's a request from it. And really the long-term vision is we go from being a data push to a data pool. Where, hey, I have the business case. If I have data X and Y, I can solve for Z. Okay, well, then I'll give you data X and data Y. Instead of, hey, I'll give you A, B, C through Z and you figure out what to do with it. We really want to get to that lean data like we've been talking about where we're pulling that data through. And the key to that is really enabling that. I think it's going to be allowing us, it will be enabled through what we've created. And HighByte is really a big piece of that.
If you were having a conversation with yourself in the past, like early in this journey, or perhaps even a peer that's early on, what advice would you provide to those getting started? And also, what advice would you provide to them for them scaling after that?
Lean into modern ideas and lean into the containerization. That has been tremendous for us. That's what keeps things moving. That's what keeps you going forward. And then just make sure you build those relationships. Build it with your integrator. Build it with HighByte. They've been tremendous partners working with us on this, and really receptive into what we need and how we're using it. Because everyone's implementation is going to be a little bit different. But certainly just reaching out to those folks and getting those partnerships.
Hi. So your UNS data model, did you follow a standard like ISA 95 or 88, or did you custom build something that made more sense?
Yeah, for the most part, we just followed that. Yeah. And I'm glad you threw out the numbers and letters because I always mix those up. I'm like, the thing, and if you try to Google it based without those letters, you can't. You're like the model, and they're like, oh, it's terrible. But yeah.
Hey, Kevin. First of all, I'm sorry I interrupted your presentation, but we needed the slides. The people love reference architectures, and you can't deny us of those. But no, my question was going to be, you mentioned in the beginning of your presentation that this is how you present concepts up to management. Could you just talk a little bit about what is the hardest part of getting management buy-in for some of these infrastructure projects? And then how do you overcome those challenges?
Well, when I get there, I'll let you know how I overcame them. I mean, we're in 41 sites and we're rolling out still, and it's still a challenge for sure. But really, it's for me, the biggest thing on this whole deal was just being really good partners on the business side. IT has not driven this. I've been able to get some things in there selfishly. I would say I am the driver of why we have the unified namespace versus the original solution that would have been more predictive maintenance only. But beyond that, it's really been my business partners that have been driving this. So it's a lot easier on the IT side, on my side, to justify when I have their MDs, their VPs, their SVPs saying, hey, we need this. We got to go. And then when we're able to deliver, and take advantage of some of these things and deliver so quickly, I know it just makes everybody's life easier. We've been able to keep pace with some pretty aggressive timelines, and because of taking advantage of some of those, modern architectures. And as a result, it's just sort of built this snowball where I don't really, matter of fact, when we went for the funding, right now, like every company, everybody's asking a ton of questions about, spend. When we went from the 40 sites to the additional 69 sites and the business went and said, hey, we need this chunk of money to do this, they just said, okay, which is kind of unheard of. But they see the results of what it is and they don't maybe understand all the details, but they understand the end result is that we are doing things differently in the field, and we are driving human behavior differently. And we're not eliminating people to do it. We're just using them more effectively. Mm-hmm.
On that cost, are you willing to share some estimate of a per site, what the OpEx spend is on one of these?
I can't do that bit. What I can say is that we are at worst cost neutral, at worst, based on the predictive maintenance use case alone. So the use case is paying for the implementation. I'll say it that way for sure. And then the additional use cases to come will definitely enhance that value.
Okay. And then is it funded by the plants or is it funded by IT centrally?
This is funded by the business side. It's currently coming out of the maintenance organization.
Okay.
Mm-hmm.
Thank you.
Yeah. And then one thing I want to clarify. When I say business partners, that's both up and down. So that's the end users as well as the data guys, the system integrator folks, the maintenance people. It's really making sure you have those relationships across the board, because the more buy-in they have, the easier it is from the IT side to sell the in-between pieces.
So we talk a little bit about, the naysayers, who wants it, who doesn't. And then primarily, it's always the scare of, well, you're going to take my job. And you just said it, that no, we didn't take anybody out. We just had them do something different. And as we look at technology, it's just like, the repetitive tasks, the things that they don't need to worry about. We need the humans think about human things. How did you convince, line operators, shift operators, that this is okay? How did you get their buy-in using the tools? And because if they don't use it, then, it doesn't work.
Yeah. And I mean, that's more on the business side. But for sure, the step one is to find somebody that's going to have that forward thinking mindset and to start with that site. So our beta site was working with somebody that was really open to the idea to begin with. And then once we kind of showed what the possible was and got them on board, they kind of became the promoters of what this is going to be. And then we kind of went to a wave 2 of folks that we knew would be more receptive. Until we get done, we're hoping that there's enough, hey, this is better and I didn't lose people, that we really don't have to do a ton of convincing at that point. It's always going to be a challenge, especially in an organization of our size. But certainly those folks in the field have felt the pain and the pressure of a downtime incident that happens 2:00 in the morning, and it's a rush to get everything you need. It's a rush to get the people. You got the senior manager yelling over, when is it going to be done? When is this going to be back up? They've all felt that pain, and they would do probably anything to avoid it. And I think they much prefer being in a space where, hey, instead of doing emergency unplanned work, I can do planned work. And that's a much, much better space to be in and to work in, where you can stage it. You can bring on the people you need to be on, and you can do the job happily.
So thank you, Kevin. That was great. Appreciate it.
Sure thing.